You traveling or
Together.
what?
Yes, I'm in a trial.
Muhammad sir, please begin.
Okay, sir. Zaid, sir. Okay, hello everyone.
Yeah.
It is my pleasure to give you this impulse amount too, and we are happy to say that we are welcoming you in this particularly very beneficial webinar. So I warm welcome you in today's webinar. Name is Importance of Mechanical Properties in Metallurgy Industry. So we have today with us is Zaid Dadi. He is a well-known metallurgy engineer in RTI services, which is mainly used for the testing and metallurgy industry. He has a very vast experience of the 3 years. He done his BTech from Indus Institute from Ahmedabad. Then after he done his MTech or a Master of Engineering from MS University in Industrial Metallurgy. Then after that, he joined Adya Engineering. He's a very vast experience in this metallurgy industry and testing all this thing. I hope you will understand today's all the fundamentals related to industries mechanical properties in metallurgy industry, and I hope this will help you in your future also. So I welcome Zahir Dadi to let's begin the presentation with this webinar. Welcome you, Zahir
Hello,
sir.
everybody. Hello, everybody. Good afternoon.
Good
As
afternoon, sir.
Muhammad Isra has already introduced me, first of all, I would like to greet HOD ma'am if she is available, Bindi Thakkar, and all other faculty members if they have joined already, and all other students if they have already joined. First of all, I would like to say that it is an honor to present myself in front of you guys. Uh, I would like to introduce myself first. Myself is Zahir Dadi. I have completed my BTech from Indus University, Ahmedabad in material science, metallurgy and material science. Later, I pursued with Masters of Engineering in Metallurgy from Maharaja Sayajirao University. So, right now I am working with Adya Engineering Services, which is located Makarpura GIDC. So basically, we are into material testing, all kind of testing like DT testing and NDT testing. So in DT testing, we are performing chemical testing, mechanical testing. In mechanical testing, we are performing tensile testings, hardness testing. Also, we are performing impact testing to find material toughness, as well as we do NDT, non-destructive testing. So uh, in today's webinar, I'm going to uh, give I'm going to give some explanation on what is the importance of mechanical properties in manufacturing industry, or you can say in metallurgical industries. So we all know that we are reliable on every other engineering aspects. So if we're talking about mechanical properties here, then our industries are most reliable on three most huge properties, like which is tensile testing, hardness testing, and toughness testing. So there are other testings, but we most reliable on these three testings. So in today's webinar, I will be giving some overall uh, details about these mechanical properties in industries. So here are my today's contents, in which I'll give you some introduction about metallurgical engineering. Then what is the then later I'll be giving some how to select the material by combining metallurgy and mechanical properties. Later I'll be giving some real life application of these applied properties, and then we'll be summarize this webinar, and then I'll be continue with Q&A for 5 minutes or something. So let's begin. First of all, what is metallurgical engineering and what does a metallurgist do? So this is a very basic question. When we heard about metal, what does metallurgist do? So that it is not a rocket science. First of all, metallurgy is a very basic field. In this, what we do is we extract ores from earth crust, then later we process it to purification, and then after we form it by applying different methods to final product. So what happens when we think about making a product? So after doing some designings and AutoCADs and designings, the question arises that what is the application of this product? Are we using it to at ambient temperature? Are you using it at our home? Are we using it at our industries? Or are we using it in some particular product like in mobile or anything else? So after designing, the question arises: what material should be used? What material we should use in this particular product? So then metallurgists come and applying some metallurgical knowledge of material phase, material properties. It decided by them that this material should be used here and this particular alloy should be used here. So what happens that we don't directly use basic metal. We make it alloy. Like if we talking about steel, then there is thousand types of steel. There is not a particular steel. There, if we see in our home, there is utensils. We can say that utensils in our use utensils in our home. There are many types of utensils with different grades. uh, we can say that all the utensils used in our home are made from different grades. So what material we should use at that particular application, what the metallurgists come. So uh, how we select this material? Okay, so basically depending upon properties, there are many type of properties: chemical properties, physical properties, mechanical and dimensional properties. Other than this, there is electrical properties, thermal properties. Depending upon the applications, we study these properties on the particular metal. Then after we apply some basic taste on that, and then we cast the product finally. So we can say that when a product is designed, when a product is designed, uh, a particular some particular when design occurs, there is some functional use of material which is very important. So if we say that some materials are good at mechanical properties and some good at electrical properties, so if application is like that, we have to use that material in both applications. So we have to make such kind of alloy. But in today's webinar, we only are going to focus on mechanical properties. And mainly in mechanical properties, we are going to focus on strength, toughness, and hardness. In here today, I'm not going to explain you what is strength, what is toughness, what is hardness, because you guys already know it better than me. So I will be giving overall strength, toughness, hardness review on this webinar, and will give you what is the actual application and how does it derive from using some machines. So from mechanical aspects, we can say that you know, from the beginning of the era, we can say that mechanical properties are very important, which plays very important role in every day. If you are making a needle, if you are making a needle, then the mechanical properties are applied. Or we if we say if you are making a submarine, then there is also mechanical properties are applied which is important to derive. So when a product is formed, then we have to conclude all the parameters which are connected to these fields. Okay, so we have to understand what is these particular properties are related as a industrial product. So when we talk about key mechanical properties, there is this 5 or 6 properties which is very important. In today's seminar, we are going to study some of them. So let's start with strength of metals. So what is strength? We already know that strength is, we can say that when a particular load is applied on a material and it's withstand up to some amount and then it's break, so the withstanding point it's its strength. On in a basic words, in a simple words, when a material is made, like when a plate is produced or a flange is made, then there is first thing material manufacturer thinks about its strength. Okay, what should be its strength? If a material is made, then if a specimen is made ready from it, and then we taste, and if a material is filled according to standards, we we work among 3 or 4 standards basically. Indian standard, ASTM standards. If it's pressure vessels, or then we perform ASME standards based on ASME standards. If other customer requirements are approached, then we perform with Japanese standards and other. So first question come with manufacturer is what is the strength of this material. So if chemical composition of all of this material is okay, then strength can be determined easily after forming the metal, after forming the product. uh, uh, let's continue with this. There is a three type of three types of mainly force are present, while mainly three forces are present. One is compression, second is tension, and third is shear. So basically, we perform tension test if we want to determine the strength of the material. Some of the application required compression test as well. So how we derive strength of such material? Let's see. We derive strength of material by stress strain curve. We all know that stress strain curve. There is 3 or 4 points which is important in this stress strain curve. Here we see there is a yield strength. As a metallurgist, I say ultimate strength and yield strength. The yield strength is important than ultimate strength. As we know that yielding point is the point where a material, up to yielding point, a material deform, uh, elastic limit is its yielding point. Okay, after that it's permanent. After that, if is load is applied, then material is permanently uh, deform. So as a metallurgist, I say that yielding point is a important factor in any material to derive a strength. So here we see that after particular load, here when curve curve is changed from here, it peak load. After this, if material strength is not that higher, then it goes down and failure occurs. So we can say that here that strength is one factor, and there is other factor which is elongation and reduction area. Elongation, you can say elongation after a specimen, after a specimen's break, then there after ductile specimens break, then there is a formation of
Hello,
V, or you
Zahir
make.
sir.
Yes, yes.
Sir, you also have a
Ye-
facility of pointer at the right bottom corner, so you can easily understand that. You can draw over screen over there. You can
okay.
see right left bottom corner.
Yeah, 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 I see.
You can see.
Yeah, yeah,
Yes,
yeah.
it will be helpful for you to explain, sir. It will be good for you.
Okay, okay. Thank you, Mama Isra. Thank you. So the question occurs that how in industry how we derive this property, how in practical application how we derive this property. So here is this tensile testing machine, uh, in which we can directly derive stress and strain by calculations, and we can we can say what is the tensile strength of the particular material. So in accordance to standard, ASTM standard and ASN standard, if we follow ASTM A370 or some others testing standards, we can find there is some particular size mentioned. There are some particular size are mentions that we have to cut from a material to check tensile strength. So here I have put a video that will be helpful to understand UTM machine. I'm playing the video.
Is a basic form of testing that can be performed on a testing machine with a testing system. Tensile test applies a tensile or pulling force to a material and measures its response to the stress. This enables engineers to assess the material's suitability for its intended application. Materials in all industries are commonly subjected to tensile forces. For example, the elasticity of tire rubber is critical to tire performance, while rebar is used in the construction of concrete structures due to its superior tensile strength. Other commonly tested materials include plastics, thin films, composites, metals, and textiles. Tensile testing is also performed on finished products, such as medical tubing and sutures. These devices are critical to patient safety, and their mechanical properties are strictly regulated by the FDA. Tensile tests are performed using a wide variety of grips, fixtures, and accessories designed to accommodate different materials and specimen shapes. While different standards require the measurement of different mechanical properties, the most common properties of interest are breaking force, modulus of elasticity, elongation or strain, and tensile strength. For more information on mechanical testing, subscribe to our YouTube channel.
Okay, so as we seen the practical of this tensile machine, how it derived tensile strength of some material. Okay, now we are going to second property, which is very important while manufacturing in industries, which is hardness. Hardness is nothing but a resistant to deformation. When we apply a direct force on some material, then the resisting parameters of it to resist to scratch or cut, that can be uh, termed as hardness. So depending upon the material, hardness varies in every material. If we talk about cast iron, then the hardness would be higher as there is a carbon content would be higher. So during the designing of the material, we need a mixture of this tensile strength and hardness. If we want to outcome with a great product, then we have the material should have higher strength, higher hardness. Also we'll discuss about toughness. Then I'm telling you right now that the toughness should be higher. So depending upon the application, the customers ask that their property should be higher in all aspects. But practically we see that if hardness is increases, the tensile strength decreases up to some point. After some point, because if hardness is higher, the material is brittle, and the hardness is lower, then the material is ductile. If we want to higher strength, then material should be ductile, as it is elongated up to higher load. And but let's see hardness, how we derive hardness, then we'll discuss how these properties are important. Okay, so there is many types of hardness method, but there are widely used Brinell and Rockwell, and some industry ask for weaker hardness as well. But in industries mainly Brinell hardness is acquired, and these Brinell hardness, Rockwell hardness, and weaker hardness are basically their founder's name. So there is nothing different about it. There is different. The difference is we use different types of ball to penetrate into material. These three methods differentiate by performance of test that Brinell hardness required Brinell hardness ball indentation, which is made of steel, whereas Rockwell hardness test having a diamond indentation shaped indenter, and also it is made from tungsten. So all of the method are reliable. Now if we see here that how it can be measured, so in a hardness machine a ball is penetrated into a material with different types of load. If the material is with if material is having higher hardness, then the ball will be the load will be higher. So after applying load, this indenter will penetrate into this specimen in material. Then after after calculation, this dia, we can say dia, you can see here d1 di. Let me, you see here, this is the surface area in which indenter is penetrated. So from that we can derive hardness. Okay, so to better understanding hardness, let's see how hardness is performed on material.
The Brinell hardness test. Using the Brinell, the hardness of a turbocharger housing is to be measured. First of all, the tester has to make himself familiar with the testing machine. The monitor and the control panel are positioned in the upper part of the machine. These are used to select and program different testing methods. Below the control panel, microscope lens with a digital camera are installed. Instruments are connected towards the test piece as required. It is also possible to select and exchange data, so different methods of hardness testing can be.
If you want to restart that video, you have to speak one more time.
Yeah, but it is not working. I can't. The laser pointer is on, so I can't play it.
Use space
So
bar also, sir.
but not working. It changes the.
Okay, sir. No problem. You can go ahead, sir.
Okay, so as we seen that there was there was a microscope was fitted with that machine to identify the depthness of that particular indenter after applying the load on material. So after counting the area and that we can derive the hardness. So there are different types of machine available, uh, and different types of testing, like I said, Brinell, Vickers, and Rockwell. And there are two more types of testing, which is not widely used. Now coming to the third properties, which is widely used in when the it is used in a uh, C product, like this Wait a minute. Okay, so toughness is a very important property for a material which is used in a C application. C application. So not all the manufacturer use this as a everyday testing, but it is very much reliable for toughness testing. So we can see that there is mainly two type of testing for toughness. One is charpy and other is izod. Among these, charpy is widely used in our industries. So first, a question arises that what does toughness mean and why it is important to industries. So, as a material, we can say that if a material is having a higher tensile, higher hardness, but if it's not having a ability to sustain certain load, then the material can be defective from the starting of its application. So the Charpy and ISO test are placed so we can derive the toughness of metals. Though we can say that if a material absorbs energy when we apply, then the toughness of that particular material is very good. So let's see how does toughness can be derived using toughness machine. We are going to see a video uh, which is showing Charpy impact test. So here it is a Charpy impact machine in which what happens, we make a specimens like of a size of 10 by 10 and the width of 55 depending upon the material thickness and other things. This particular size uh, is derived from our ASTM and ASME standards. If for an example, if we are planning to make a submarine or something like that, then there is chances of sudden impact of ice and other sea things that would be higher on submarine. Okay, so what these people do is that to that particular at that particular temperature, people we taste this specimen so we can derive its absorbing energy property. So this specimen can be tested on different temperatures, ambient temperature or minus degree temperature or 0 degree temperature. So depending upon application, we use temperature and specimen size to check impact energy, absorbing energy of the particular sample and particular material. So let's see how it is done.
All Pro-Threaded products operates under the API Q1 quality management system and holds the licensing for critical fasteners under API 20E and 20F for bolting standard levels 1, 2, and 3. These and other certifications are made possible through the efforts of our highly trained quality staff using the very latest and sophisticated equipment.
The Sharpie impact test, also known as the Sharpie V-notch test, is a standardized high strain rate test that measures the amount of energy of the material before it fails. The sample used is a machine to 10 layers with a V-shape. This is known as a Sharpie. It is cut at a specific dimension to meet the relevant Sharpie testing requirements. The measurement needle is manually adjusted to 0 on the scale, ensuring that the energy absorption can be properly recorded at the point of impact. Depending on the type of material, the specimen can be tested at between an ambient atmosphere to minus 150 degrees Fahrenheit. The sample piece is an ASTM A320L7 stud, which requires the testing to be conducted at minus 150 degrees Fahrenheit. Once the required temperature is obtained, the specimen is held for a measured period of 5 minutes. To begin the test, the Sharpie hammer is lifted into position and held in this position until the test specimens are cooled to the required impact temperature. Following this wait period, the Sharpie hammer is released, the impact is administered, and the impact absorption is measured. This process is repeated a total of 3 times on 3 identical specimens, and the average of all 3 measurements are reported for the set.
Okay. After studying these three properties, I would conclude that in our industries, in particular mechanical properties, these three properties are having very huge impact. Mainly, these three properties are reliable for finalize the product if we are talking about mechanical properties. Other than these, all material industries are reliable on all kind of properties, but specifically to mechanical properties, I can say that uh, these tensile hardness and toughness properties are very much important to any material. So I would like to conclude this year. And if anybody has any question, you can ask me. I will try my best to explain.
Thank you, sir. Really appreciate that. Sir, I have questions from the students. One by one, I will ask you. Okay, sir.
Yeah, sure.
So you can just answer. So the first question is, sir, what makes metallurgy unique than other branches? Can you in fast way explain?
What makes metallurgy unique than other branches?
Sir.
I would say every branches are unique in their own way. But if I say that when a particular product is made after designing a particular product made, and what if that if we talk about its tensile strength, what happens if tensile strength is not good? What can we do is we can perform a heat treatment. So basically metallurgists know that what should he do or her do on a particular material or particular area to improve its properties. So એવું કશું નથી કે મેટલર્જી યુનિક છે, મેટલર્જી એટલે કે જે એન્જિનિયરિંગ યુનિક છે, બધી બ્રાન્ચો પોતાના પેલા પર યુનિક છે. We all are reliable on each other.
Thank you, sir. Sure, sir. All our branches are relatable with
Yeah,
each other because without support of any branch, we can do not do anything in engineering. Sir. We have to help
yeah,
every engineering branches
everything.
develop.
Yes, yes.
So, it's a very good answer, sir. And here is the second question, sir.
Yeah.
Mechanical engineering or metallurgy engineering? What is better?
Another difficult question. So I would say, as I said, that there is nothing like any particular thing is good, but we have to study all aspects. Like I said, that when the product is designed in AutoCAD or a basic of product is designed, then electrical engineer, chemical engineer, also a metallurgist will come to finalize that product. So I would say if I'm studying metallurgical engineering, then metallurgical engineering is okay. But I would like to know other things from mechanical engineering so that I combine those things and apply it to my knowledge so it can benefit our world.
Sure,
So
sir.
and
Yes, sir. Continue.
every branch are good at its own way.
That's right.
Any other questions?
Sir, one more question is there. Sir,
Yeah,
students are saying that the instrument you are showing right now, the
yeah,
testing,
yeah, 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 yeah,
they have also seen this type of instrument in concrete lab.
yeah,
In
yeah, yeah,
just structure in civil engineering, there are structure
yeah, yeah,
engineering, analyst. They so
Yeah, yeah, yeah,
this similar type of instrument over there. So they also have a
yeah,
help of metallurgy engineering their own level, or they have individual department for them.
yeah,
वो ऐसा पूछना चाह रहे हैं कि सर
yeah.
हमारे पास भी ऐसा इंस्ट्रूमेंट उन्होंने देखे हैं कि ये दोनों कोरिलेट है, या फिर वो अपनी रीत से ही मेटलर्जी अलग से करते हैं.
नहीं, 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 मतलब जो मशीन ये लोग यूज़ करते हैं वो टेंसाइल मशीन ही है, जिसमें मतलब कंक्रीट के लिए, कि कंक्रीट के अंदर यूज़ होने वाले वो टीएमटी बार्स
नहीं,
के लिए।
उन्होंने देखा नहीं है. नहीं, उन्होंने
नहीं,
देखा तो नहीं है, बट उन्होंने यही सेम मशीन्स वहाँ पे देखी है, हार्डनेस के लिए, टफनेस के लिए, ठीक है सर, सेम मशीन्स. तो यही मशीन है या दूसरी
बट
मशीन है, वो ऐसा पूछना.
इफ यू नहीं, यही सेम, अगर मटेरियल है, मेटल है तो मशीन सेम है। अगर कंक्रीट है, मतलब कुछ दूसरा मटेरियल है, लाइक पॉलीमर है, कंक्रीट है, सिरामिक है, तो उसका मेकिंग अलग होगा, लेकिन प्रिंसिपल सेम होगा। एनी अदर क्वेश्चन? You are not audible, Mohammad Ishra.
Shape and all these things you saw in, so they think that metallurgy is also applicable. Metallurgy is also applicable over there.
I didn't hear your question. Your voice is breaking, Mohammed.
They are audible. They are. Hello?
You are not
Hello.
audible, Mohammed.
Yes, sir. I'm audible.
Your voice is breaking. Yeah.
Hello. Yes, sir.
Yeah,
Am I audible to
you're
you now,
audible.
sir? Okay.
Yes.
So they are mainly asking that the instrument where it is used over there, they also have a help support of a metallurgy engineering in civil.
Yes.
सिविल वालों को भी
If
मेटलर्जी
you
की
are
जरूरत
talking
पड़ती है.
about any industry, yes, if you are talking about any industries, there is a quality engineer. If you know that, there
Yes,
is
sir.
a QA and
Yes,
QC.
sir.
So for particular that post, metallurgical engineer should be hired there.
Okay.
So
So, sir,
metallurgy
they are
is
very
not about
satisfied with
only
your
metals.
answers and all this.
Muhammad, let me complete.
Yes.
I was saying that metallurgy is not about only metals. It is about metallurgy and material science are combined. In material science, we also study about other materials like polymer, ceramic. दूसरे materials are included. So we can say that when is a
Okay,
product
sir.
comes of any kind of material, then there should be a metallurgist. मेटलर्जिस्ट की जरूरत वहां पड़ेगी.
Hello.
Yeah.
Yes, sir. Very satisfied with your answer, sir. Very satisfied with your answer. Am I audible to you, sir?
Yeah. Honestly.
Hello. Okay. So, sir, very
Yes,
good
yes.
seminar and very
Yeah.
good importance of these material properties in the mechanical engineering aspect of the metallurgy industries. So they know how it is the importance and what are the tastes and all these things. So it is very good to hear you, sir. And it is we are very thankful from the Parul University and all the mechanical engineering staff on that you have spared your valuable time for this webinar, sir. And we are very happy to hear you over here. And one more time, sir, thank you so much for giving your precise time and give us this
Yeah,
knowledge
sure.
about this metallurgy.
It
It's a pleasure to honor you, sir.
it's an honor. It's an honor to study with you.
Yes, sir. The same thing will happen with us if we are in the school, sir. So it will be beneficial for us. So we can say that we have shared our classroom, sir.
If you arrange next time a webinar, guest lecture,
Yes.
kindly arrange it to
Yes.
college, so we can
Yes, sir. We are
intersect with students.
okay, sir.
Yeah,
We
that
will
will be
share,
very
sir.
helpful to
We are
me
we
and
are planning.
also students.
Yes, sir. It is will beneficial for them. We are
Yeah,
trying for that, and we are on a working on that. In June, we are almost over there, so we will inform you for
yeah,
that, sir. Sure, we are inviting you for that, sir.
okay.
Sir, thank
Also,
you.
I'm very
Thank you one
thankful
more time
to
for the
you.
joining, sir.
I'm also very thankful to you, your department, and Parallel University for giving me such a great opportunity to show myself in front of you. Thank you so much.
Yes, thank you, sir. Thank you, sir. Have a nice
Okay.
day. Nice to meet you, sir. You may leave now, sir. We can also leave.
Yeah.